So I want to start you guys off with a quote today. Leonardo da Vinci once said, "Simplicity is the ultimate sophistication." And on that theme of simplicity, I want to show you guys today just how easy it is to work with Snowflake. And the reason we're able to work with it in such a simple capacity is because our architecture has been built from the ground up specifically to leverage the cloud. Extremely sophisticated architecture. And pretty much every feature I show you today is going to boil back to that architecture and how we've been able to build that fresh. And it was originally built for AWS. We are multi-cloud today, but again, originally for AWS. So I'm going to give you guys a bit of a background on the company, where we've come from today, little bit about the history and the founders, and what we are as a product. So Snowflake was founded in 2012 by industry veterans with over 120 patents to their name. Two of our founders, Thierry and Benoit, came from deep in the bowels of Oracle. Very, very senior leaders in their dev team. Our third founder, Marcin, was literally the man who invented vectorized query patterns. So we've got some incredibly smart talent that's built Snowflake again from the ground up, a brand new architecture. We currently have about $1 billion USD in venture capital funding. Some huge investors that have invested in Snowflake out of Silicon Valley, currently taking our valuation to $4.5 billion USD. We're currently one of the fastest growing SaaS companies of all time, if not the fastest. So absolutely phenomenal growth. And that, jumps into the employee count that I've got up there. So currently over 1,300 employees today. When I started with the company about 9 months ago, I think I was number 520. So absolutely phenomenal growth in a really short space of time. And of course, we got our first customers on board in 2014 and went GA in 2015. We actually spent our first 3 years in stealth mode. So we built this product from the ground up. It's not based on anything. I'm going to dive into the architecture today and talk to you about how Snowflake is absolutely different from every other on-prem or even other cloud solutions today. So a few fun facts about Snowflake just to kick us off before we get into the architecture. And of course, I am going to do a really thorough demo today as well. So I'll try and get through the slides as quick as I can. So here's some fun facts. In Snowflake, queries processed per day globally, 165 million queries. This is a huge system. Our largest single table, which belongs to Adobe, 68 trillion records. The largest number of tables within a single database is in excess of 200,000. Single customer with the most data, this belongs to Capital One of the biggest banks in the US, 55 petabytes. And they don't need to spin any of that down. That's all analytically available at their fingertips whenever they need it. And the single most concurrent users on a system in one account at any given point in time, in excess of 10,000. So what is Snowflake? We are a data warehouse. We are ANSI SQL standard. So you open Snowflake from day one, we're going to look and feel very familiar. SQL data warehouse, except we've been built specifically for the cloud, and of course, we are delivered as a service. We are a SaaS product, as I mentioned earlier. So throughout the demo today and throughout the presentation, take note of all of the things that I'm no longer having to do. All of the data janitorial work that you have come to expect from other systems in the past, like writing indexes, managing partitions in your database, this is all gone. There is no performance tuning to be done in Snowflake. You simply pick up your data, you pour it in, and it just works. Going back to that vision of simplicity again. So why Snowflake? Why do you need yet another data warehouse? I want to give you guys 6 reasons as to why data warehouses today are just not working. Now, I think commonly most data warehouses that you do pick up will be able to solve 1 or 2 of these issues. Snowflake is the only one that's going to give you all 6 of these. So complexity, I've already spoken to the simplicity piece. You don't need to think about provisioning for certain workloads anymore. You don't need to worry about how much compute you're running. Snowflake flexes to any size that you need it to, whenever you need it to. And you guys will see this in the demo as well. You've got 100 megabytes today, you've got a petabyte tomorrow. There's absolutely no capacity planning to be done. You don't need to do that anymore. You don't need to run overnight jobs because we have zero contention on our system. You can spin up an unlimited number of compute clusters over a single copy of the data. Inadequate elasticity. In Snowflake, you can scale both vertically for performance and horizontally for concurrency. The concurrency piece, again, one of the biggest reasons why Capital One moved across to Snowflake from other cloud products. Rigid cost. We bill you guys per second. So think about running a query for 2 minutes, and once that query finishes, all of your data, of course, is persisted, but you pay for only those 2 minutes that you're running your queries. Diversity of data as well. You no longer need to spin up siloed data marts because you've got contention in the system. Snowflake flexes to any size you need whenever you need it. It's all at your fingertips, and all of your data is always analytically available. We can also handle semi-structured data. So we can natively ingest into our brand new variant column, which is currently patent pending and very unique to Snowflake, natively ingest awk, avro, parquet, XML, and JSON. And we actually optimize and columnarize those payloads on load. And then you can interrogate those payloads by simply referencing the key value pairs that sit within them with simple SQL syntax. It just works. Data sharing as well, very unique to Snowflake. So we are now multi-cloud. So yes, we started on AWS. We've gone live on Azure as well. And by the end of the year, we're going to be live on GCP also. So imagine a world where I've got an account on AWS, my customer has an account on GCP, they want to share a table with me. Without ever having to leave Snowflake, I can select star from their table within another cloud. There is no one else doing this at the moment, and this is what truly excites our executive today. So how does Snowflake make things easier? I want to give you guys a bit of a background on traditional architectures and then talk about Snowflake's architecture, which is, again, has been completely redesigned from the ground up, and talk to you guys about how that's a little bit different. So just quickly, shared disk. Typically with shared disk, IOPS become the bottleneck as you start to scale. These two architectures as well, these were invented back in the mid-'80s. So, a lot of people refer to the term vintage as something being, between 30 and 100 years old. So kind of refer to these architectures as both being fairly vintage today. They've been around for a long time, they work really well, but they do have their challenges. With shared nothing, because your storage layer and your compute layer is so tightly coupled together, if you want to scale it, you're forced to scale both aspects of it. If you want more CPUs, well, you've got to get more storage with it. If you want more storage, well, you've got to get more CPU. And you don't really have that flexibility. So it's highly scalable, but it's not exactly elastic. So with Snowflake, we've actually separated these two layers completely apart from each other. And we now have a new architecture which we call multi-cluster shared data. You can spin up as many compute nodes as you want within as many different siloed clusters over a single copy of the data without ever having to replicate across multiple environments. And this is how that architecture looks. So at the core, at the storage layer, we leverage S3. That's infinitely expandable. The size of S3 in Snowflake is the size of AWS, right? You can put as much as you want in there. That's why Capital One have 55 petabytes in their account, always analytically available. And then you can spin up as many compute clusters as you want over that single copy of the data, always with zero contention. So unlimited storage scalability without ever having to refactor. Resize your clusters instantly. If you've got a 4-node cluster, you want to go to an 8-node cluster, that'll take you a couple of seconds. You just hit a button and that's done. I'm going to jump into the demo really soon and show you guys exactly how that works. So sounds great, show me more. This is the data set that we're going to be using for the demo today. So I'm going to jump into Snowflake, and then I'm going to switch across into Tableau to visualize this data. But we're going to load up a bunch of records from the City Bike Manhattan dataset. It's a publicly available dataset. You guys can get access to that too. Essentially, we're going to look at the trips table. You pick up a bicycle from a location A, you drop it off at a location B, and you pay for a trip. I have created simple DDL, a table structure that I'm going to copy some data into out of an S3 bucket. This is my S3 bucket, and I've got a bunch of zipped CSV files in there. So I'm going to jump over into the demo now and show you guys this live. All right, so the first thing to note, this is the Snowflake UI, so super simple. Looking at this from the get-go probably looks quite familiar to most of you, not too dissimilar to a SQL Server or something like that. But of course, we've completely separated these two logical objects, right? Databases and virtual warehouse clusters are completely separated. Think of this as being S3 and this as being EC2. Whilst I talk about EC2 and S3, you never physically have to interact with those layers. We manage all of this for you. So here is my city bike database that I've created. Just checking my time here. All right, we are good. I have created the trips table like I showed you before. This just has a bunch of empty columns inside it right now. I'm going to load some data into this trips table, and we're then going to continue with the demo. Now, for the purposes of the demo, I'm going to use two personas today. Currently logged in as John, who's our DBA, as you can see up here, sitting inside the DBA role. The second persona is going to be Jane. She's going to be managing Tableau. So as we jump across into Tableau, we're going to have different permissions in a different role, and she'll manage the BI side of things. And we'll do a little bit of correlation analysis and stuff like that. So I'm going to load up some data, but before I do that, I need some compute, because right now in my Snowflake account, I'm paying for absolutely nothing. I've got no storage, and I'm running no compute. All I've done is run DDL, which is free. So I'm going to create a virtual warehouse cluster. I'm going to call this the load warehouse. We're going to use it to load some data. And the very first option I get here in Snowflake is this t-shirt sizing that we use to select the size of your cluster. So this is what we call vertical scalability. This is, how big are your data sets? How big is the problem that you want to tackle? You need to scale vertically to address these issues. The default setting here is extra large. We increment doubling each time. So, an extra small is 1 node, which also consumes 1 credit per hour. A small is a 2 node, a medium is a 4 node. It continues to double all the way up to a 4XL, 128 EC2 nodes in a single cluster. I'm going to spin up an extra large. Again, that is our default value with 16 nodes in it. I'm not going to use multi-cluster warehouses right now, but just to tell you guys what this is to scale horizontally for concurrency. Imagine I had a medium warehouse, which was 4 nodes in my cluster. Imagine on a Monday morning, I had 1,000 people using the system all at the same time. They're not asking harder questions. They don't have bigger data sets. There's just more people on the system. I don't want to scale up for performance. That's not going to help me in this scenario. I want to scale out for concurrency. So if I was to set my upper boundaries to 10, that's telling Snowflake that I'm allowed to spin up additional copies of that same medium-sized warehouse in order to drain my query tap faster, reduce queuing. In Snowflake, there is no queuing if you have this set up correctly. Doesn't matter how many users you have. Again, capital 1, over 10,000 users concurrently. I'm going to set this to 1. I'm the only person on the system today. I'm going to be jumping across to Kelly later, who's going to help me out with some data sharing, but 1 will be enough for us today. I'm also going to set my auto suspend to 5 minutes. Now this means if I don't use my virtual warehouse cluster for up to 5 minutes, it's going to automatically shut itself down and we're going to stop paying for it. Keep in mind, because this layer is separated from storage, the S3 layer where all of our storage resides is always going to be analytically available whenever you need it, even though your compute cluster's shut down. So let's set this to 5 minutes. I'm going to leave auto resume ticked, which means the very second I fire a SQL statement back at this cluster, it's going to instantaneously wake back up. And we'll see that today as well. I could also do this in SQL, right? I'm just using the UI now to make it nice and simple. I will do it later with SQL as well. So 16 nodes, they're now running, they're active. That took me probably 100 milliseconds. We're good to go. We're going to load up some data here. I'm going to set my context. Sorry, I'm in an earlier sheet here. Here we go. Just setting my context here. So I'm using the DBA CityBike role. I'm in the CityBike database. This is my production environment. I have a staging bucket, which is literally an S3 bucket that I've connected to my account. Now, this S3 bucket has a bunch of zipped CSV files inside it. This is what I'm going to load into my trips table that I showed you before. We're going to use the copy command, which literally says, copy into the trips table from the stage where the files are equal to 2018. There's about 5 years of data inside this stage right now, but firstly, I just want to load up 2018. So that's loaded for us in about 10 seconds here. We can see the query history off to the side. I can even do a bit of a zoom here for you guys. So we've loaded that up in about 10 seconds. And we now have 130 million records inside our trips table. Now, we do have a lot more records because there's still 4 years to go, but before loading up those 4 years, I wanted to show you guys how we can scale in Snowflake and how fast we can do it, how fast we can flex the system. Now, what I want to do is copy the rest of those years into the trip table. I want to use a larger compute size to do this, but I only want to pay for that compute for the very seconds that I'm running this copy command. So let me show you this first. This is what we've loaded up. This is just a summary of the table. I'm just doing a quick top 20 here just to show you what it looks like. Just a basic structured table as you'd expect. We're going to load the rest of the data into it. The first thing I'm going to do is alter the warehouse to a 3XL. I'm going to add 48 nodes of EC2 to my cluster virtually instantly. So I'm going to run this here. That takes me a couple of milliseconds, and you'll see I'm now running a 3XL. I'm now going to copy into the trips table the remaining 4 years that we haven't ingested yet. But I'm doing that on a 64-node EC2 cluster, all in a single node. This is only going to take me a few seconds, and the very moment that this is finished loading up, I'm going to spin the cluster back down to a large. I started with an XL, which is 16. When I spin back down to a large, I'm going to have 8 nodes in my cluster. Right, so this is finished loading. It's taken me about 20 seconds. Going to scale the warehouse back down. So we've just dropped off 60-odd nodes there, 50-something nodes. And if I do a quick count, I've now got 1 billion records inside my trips table, right? So we've just loaded up 1 billion records into Snowflake just from zipped CSV files sitting inside an S3 bucket in under 30 seconds, or about 30 seconds. So that's now analytically available. We're only using 8 nodes of EC2 now, so we're using really small compute. We've scaled right back down. But now that it's inside our architecture, I can query it really, really fast, right? I've just written a very basic aggregation here. This is aggregating all of the trips by hour of the day and pulling out a bunch of metrics that I want to see about this trips table, right? So I've summarized all those metrics, but I've run an aggregation over 1 billion records with only 8 nodes of EC2 now. Now I'm going to suspend my cluster. I don't need it anymore. I'm going to go across to Tableau. I'm going to use a different cluster. So I'm going to manually suspend it. My compute's now turned off. All of that data is inside Snowflake. We can use it whenever we want. And I'm also, this is currently set to a medium. This is currently set to a large, which is 8 nodes. I'm going to spin this down to a medium, which is 4 nodes. But it's still turned off. It's just a logical object. So the very second I fire a query back at this object, it's going to wake up with 4 nodes next time, because that's all I'm going to need for the rest of the demo. So now I'm going to switch across to Tableau. And actually, just very quickly before I do that, you'll notice that in my virtual warehouse tab, I've just got the load warehouse. 4 nodes of EC2 which are suspended, so I'm not paying for them right now. I want to have some separate compute that I'm going to throw at Tableau. I don't want to have any contention in my system, so I'm going to spin up 2 additional virtual warehouse clusters, but I'm going to spin them up in a suspended state. So I've just created logical objects here. So I've got 2 more clusters now. I've got an extra large and a 2XL, 16 and 32 nodes, but they don't exist yet. These are just logical objects, right? They're suspended. But the very second I open up Tableau, these are going to wake up. So let's do that now. And I'm going to log in here as Jane, as I mentioned before. See if we can get this to sign in. I'm going to do a quick refresh here. Let me refresh that again quickly, and we'll see that the BI warehouse, which is an extra large, is now started. So the very second I opened up Tableau, because I had the correct access for Jane, she instantiated the 16 nodes of EC2 through Tableau into Snowflake. Now, Tableau is just one of the BI tools that I'm demoing today. You could do this with Power BI or Looker or Click or whatever you want to do it with. We've got native connectivity with all of these tools through ODBC, JDBC. They all work. But for the purpose of the demo, we're using Tableau today. To switch back to Tableau here, you'll now see that I have streamed in live the 1 billion records that's in the top corner there. Now, the really cool thing about this, I can remove this little panel here. There we go, full screen. I've got my pickup locations on the left-hand side of the screen. I've got my drop-off on the right. As I start to click around in this map, you'll see that for this individual click, it generates all of the correlated drop-off locations that are associated with that pickup location. Each time I click around in Tableau, without running a compute cluster that's that big or that heavy, over 1 billion rows of data, This is actually sending SQL statements back to Snowflake and only bringing back down the results that I need in Tableau, which makes this incredibly fast. The reason this is so fast is that Snowflake is sitting behind Tableau and processing all of the compute as I interact with this chart. Now that I've generated a few clicks here, again, each click is a SQL statement that gets automatically generated. I can jump across to my query time dashboard where I've actually tapped into the metadata repository of my account. We collect absolutely every statistic in Snowflake associated with every query that you run. If you do anything in Snowflake by default, you generate a unique query ID. Now these unique query IDs are represented here by bubbles. So each one of these bubbles is one of the clicks that I've just done. And there was a little bit of caching as we opened up the workbook here for the first time. But as I was interacting with that chart, you can see that my query results were coming back to me in about 0.9 of a second. This is all coming through live. You can track this on the go. This is a very basic representation of the metadata. You can go all the way down to a subquery level and say, gee, how long did I spend scanning cache and all that kind of cool stuff? But just keeping this high level. You can actually see the physical SQL statement that Tableau automatically generated and sent back to Snowflake and then brought back down the results to Tableau. So that's pretty cool. But what we want to do now that Jane has been playing around with this data set for a bit, she wants to add something more to it. We want to overlay some weather data here so that we can do a little bit of correlation analysis. So she goes back to John and says, okay, John, I want you to load up some weather data for me. So John comes back into Snowflake. Lucky enough, we have some weather data ready to go as well. I'm going to set my sheet's context here. The first thing I'm going to do before I start playing around with my weather data is I'm currently in production. Now I want to be a good DBA. I don't want to wreck anything in my production environment, so I want to create a clone of my production environment so that I have a dev environment to play with. Right? I'm going to run what's called a zero copy clone. This takes me a second and a half. If I go back to my database tab here, you'll see that I've got CityBike and CityBike dev. That's my prod and my dev. Now, each of these tables, the trip table with 1 billion records in it, is about 15 gigabytes in size. Now, the total size on disk is not 30 gigabytes, it's 15 gig. We didn't replicate the data. We only replicated the logical object that is a database. And then, of course, if we make changes to either environment, we're simply creating deltas of those changes. Right? We never duplicate in Snowflake. It's very, very cost effective. I'm going to go back to my worksheets here. Now that I've got that environment up and running, I'm going to spin up another virtual warehouse cluster, another 16 nodes of EC2. I run this, and within 300 milliseconds, my 16 nodes are up and running. I have another S3 staging bucket that I've pre-prepared. This time, this staging bucket just has a bunch of zipped JSON files in it. I'm going to show you guys how Snowflake handles semi-structured payloads. Again, we natively ingest awk, avro, parquet, XML, and in this case, JSON. So let's load this up here. Before I can load it, well, actually, before I want to load it, I just want to quickly show you guys what this JSON looks like. It's fairly complex JSON. It's got a bunch of nested key value pairs here. We've got arrays in there as well. We're going to be running some SQL queries on that after I've ingested it. Firstly, we're going to create the weather table. I'm going to do the exact same trick I did last time. I'm going to add an additional 48 nodes to my cluster in a couple of hundred milliseconds. This is now a 3XL. So I just added, 300 milliseconds. I've got another 48 nodes in my cluster. I'm then going to ingest all of that weather data, all of that JSON payload into my variant column. Now again, that variant column can natively ingest JSON. And as we start to ingest that JSON into that variant column, underneath the covers of the variant, we're actually columnarizing the key value pairs that exist within the JSON. So if you've got 50 key value pairs inside your JSON, inside your semi-structured payload, we identify all of those and we columnarize them underneath the covers. And we get two things because we do that. We get columnar compression, which is massive, and we get massive performance gains as well. Because we're no longer having to do string searches within that semi-structured payload, we're actually going to reference those individual key value pairs themselves with simple SQL syntax. Snowflake, of course, has added some SQL syntax to the ANSI SQL standard so that we can handle these semi-structured payloads. So that's run for about 50 seconds, 56 seconds here. I'm going to spin back down to an extra large. I don't need all of those nodes anymore, so let's drop 48 nodes out of my cluster so that we're no longer paying for them. Keep in mind, those additional 48 nodes, yes, it's a lot of compute, but I paid for it for 1 minute. And I ingested, what have we got here? I think we've got about 500 million records of JSON. There we go, 430 million records of JSON been natively ingested into Snowflake. And now that they're inside our architecture, we don't need all that compute anymore. We're just running an extra large. I can show you what that looks like. We've also stripped out the timestamp here to make this perform a little bit better as well. And we did that on ingest. So let's have a look at the JSON. The JSON still looks like JSON, right? We haven't actually done anything to change it yet. But underneath the covers, it's been optimized, right? So let's have a look. Let's try and dive inside this variant column. I'm literally referencing the city.name key value pair within that semi-structured payload to search for the word New York. I'm also reaching inside the weather array for .main where that is equal to snow. I've just queried 500 million records of JSON. I've found New York. If I go down to the bottom here, I've got my weather array, I've got main, and I've found snow. So very rapidly, without too much compute, once you've ingested into Snowflake's architecture, you can start to interrogate these semi-structured payloads. You no longer need to write a custom Python script or some kind of other scripting language that you use to clean up these semi-structured payloads. You just throw them into Snowflake. Do all your transformation inside Snowflake. It's too easy. And keep in mind, we've currently right now worked with 1 billion records of structured data, 500 million records of semi-structured data. What have I not done? No indexes, no partitions, no vacuuming. There's no performance tuning to be done at all. Snowflake just works. It's simple. So now we're going to do something a little bit more complex. This is an additional feature in Snowflake called a lateral flatten. A lateral flatten is very similar to like an unpivot in MS SQL Server terminology maybe, or Oracle. We're essentially flattening out the array because I know it has one-to-many values in it, the conditions array. And once I've flattened out that array, I've then aggregated it back up. So I've run a heavy group by and a lateral flatten. And on only 16 nodes, over 500 million records of JSON, this has taken me 6 seconds. This is too easy. So now what I'm going to do, I'm happy with this. I know that my weather data is working. I want to load it back into Tableau. I've tested it. It's all good. It's good to go. I'm going to clone my environment back to production. I'm done with dev. I don't need dev anymore. I run the clone. Takes me half a second to do that. I'm then going to drop my CityBike dev environment. Don't need it anymore. I'm going to drop my dev warehouse as well, so I'm no longer paying for those compute nodes. And then going to set my context back to production. So you'll see I'm back in the load warehouse. That's a medium. It's currently turned off. I'm not paying for it. I've just set that back as the logical object that we're about to fire up. And I'm back in the production database. So I'm using production data now. What I'm going to do here is I'm going to reach inside that variant payload over and over again to get all of the different key value pairs that I want to send back to Tableau. Now, Tableau is not going to know what to do with a variant because it's a very unique column to Snowflake. So I'm going to grab all of the pieces of that variant that I want and feed them into different columns, do a bunch of conversions and stuff like that. And I'm going to represent that as a view. Now have a look at this. When I execute this DDL statement, and it's very important that this is only DDL, you'll see that my virtual warehouse cluster has not even turned on yet. I just created a view, and that was free. You can be doing that with no compute and no data if you want. So you can play around with DDL whilst your account is sleeping, so to speak. But the very second that I run a query on top of that view, you'll see that this load warehouse, right, which is currently not green, it's turned off, it will wake up. Because the very second I throw a SQL statement at it, it's going to instantaneously wake up here and it's going to execute my statement for me. I don't even need to think about provisioning these nodes. It just happens for you. Because I've told my virtual warehouse cluster to auto-resume the very second I interact with it. Right, so now I've got just a top 20 rows just to show you guys what this view looks like. On the left-hand side, we have all of the trips data that we dealt with before. And off to the right-hand side, in a really nice, clean, structured view, we've pulled out all of the different key value pairs out of that JSON payload and just left-joined it onto the side of that table. So super simple. And we're now going to send this back to Tableau and do that correlation analysis that I mentioned earlier. Let's just do a quick count star. So we should still have our billion records here, and we do. See if I can zoom in there for you guys. So just over 1 billion records here. And now I'm going to switch back to Tableau. First thing I'm going to do is just refresh my data sources. Oh, and that's actually already happened. So there is my trip weather view. I'm going to drag that over the top of the trips table. This has got the same columns in it. It's just got some additional columns that I'm going to use to do that weather correlation analysis. Go back to my by-week chart, my time series chart here, and I'm going to grab the average temperature in Celsius. Drag that over the top and do a quick overlay here. Just going to grab the average temp. Now, the weather payload is only 1 year worth of data, so we're just going to filter out the difference because we've got 5 years worth of trips data, so I'll just remove these nulls for you, make this look a bit cleaner. I'm going to grab this average temp. I'm going to make it a nice cold color. I want to show you guys how many crazy people in Manhattan are still riding their bikes when it gets really cold. And let's grab that average temp and make this a line so it's a bit more obvious. And let's go a little bit more granular and make this daily. Now, like any good demo, hopefully, we've got a pretty strong correlation here between how many people are riding their bikes in Manhattan and the weather. So, when we're getting up around 80,000 people here, the weather's around 25 Celsius. That makes a lot of sense. We've still got some crazy people down here. Our smallest number there is about 2,000 people riding their bikes when we're getting down to about negative 20 Celsius, which is pretty damn impressive. But now I'm going to flick back across into Snowflake and show you guys data sharing. But before I do that, just to call this out really quickly, that's 1 billion records of structured data in that trips table overlaid with a view that hasn't been materialized as well. This is just a standard view with 500 million records of JSON, and it's in Tableau and it just works, right? We're not even throwing that much compute at it. It's just nice and easy. And those JSON files can change their structure every day. Just continue to load them into Snowflake. As long as you've still got the same key value pairs inside them, the view's going to work indefinitely forever. And if you have additional ones, we'll just throw nulls. So it works. It's very, very flexible, very simple to work with. I'm going to run through data sharing really, really quick. The whole concept around data sharing is if I have an account, my customer has a Snowflake account, without ever having to leave my account, I can do a select star from their account if they've given me access to do so, right? So you can share whatever you want to share. If your customer doesn't have a Snowflake subscription, you can still share data with them. You can spin up what's called a reader account, and that's what I'm going to do now. I'm going to set my context here, and I'm going to quickly create the city bike share. I'm going to grant a bunch of objects to that share. So the city bike trip weather view that we just created. Let's have a look at these shares here. So we've got the Jersey City Housing Authority and the New York City Housing Authority, two different shares that we want to share different types of data with. They've got different subscriptions on this table. I'm going to add both of those guys' unique URL pointers to my share. So we can actually send them a URL. They can open that up anywhere they want in the world, and they can access the data that I've allocated to them. Let's have a look if that's worked. There's our 2 pointers that have been added. And these are the objects that we're sharing with the reader account. I'm actually going to run this part of the demo with one of my colleagues who's sitting in the front row. She's going to lock down this data share as I start to interact with it. So I'm going to log into this data share account right now, this reader account. Here's my NYCHA, New York City Housing Authority account. I literally click on this URL. It opens a new login for me. And again, you could send this to your customer anywhere in the world. They would simply log into Snowflake. And when I log in here, I should be able to see that share that's been shared with my reader account, and the data itself won't be replicated. This is just a window into my master account, right? So I've allocated a compute cluster to these guys so that I can track their usage. If you want to, you can do what Nielsen Data do today, and they actually monetize this and charge this back to their customers as they consume their data on the fly, which is absolutely phenomenal, and we encourage that. Let's have a quick look at the shares here. I can see that the city bike share is coming through. I'm going to create a database on top of that share. I'm going to import the privileges I've assigned. I'm then going to see what comes through. So I should get my billion records right now that are streaming straight through into my reader account. And again, I'm just running a very small 4-node cluster here. I've just done a quick count star. There's my billion records. I'm going to run an aggregation here on all of the different subscription types that are within that share. And the first thing that we're going to notice is that there's a whole lot of nulls here. I want to clean those nulls up. That's dirty data. There's about 900 million records of those nulls. See if I can do a quick zoom here for you guys who are up the back, just so that you can see it. So these 900 million records, we want to remove those dirty data. Kelly would have already done that for me because she's logged into another instance of my account and is working on it simultaneously. So if I run this again, we'll see those nulls no longer exist because she just ran a DML statement to clean those up, right? So they've now been deleted. This is a live data share. We're not replicating data here. I'm looking at exactly what's happening in production. So those nulls are now gone. If I run my count star again, I've now got 129 million rows down from the billion because they've all been deleted out. But what I want to do now is restrict my access because I can see all of the different subscription types within this trips table. I want to make it so I can only see the New York City Housing Authority subscription lines. So if I go down here, Kelly will have now granted me access to the secure trip view, which should only be relevant to the rows inside my subscription. And now that she's granted me access to that, I'm pretty sure if I try to run this one again, it's going to fail because she's denied me access to the full data share, which is exactly what I want to happen. I don't want to be able to see everything. I only want to be able to see the records that are relevant to the New York City Housing Authority. And that's what she's done for me. Every single record that's like the word NYCHA, I now have access to. The rest of the table, I don't, right? So this is just a live data share, and we're interacting with this live on the fly. Now, I know we're short on time. I'm going to race ahead here. That is data sharing. I want to show you, not Tableau, but I want to show you one of the coolest features in Snowflake, which is our continuous data protection and time travel. This is completely unique to Snowflake, and I always like to say this is one of the main reasons I decided to join the company. When my boss first did this demo and I saw him do what I'm about to show you guys here, I went up to our VP of APAC, Pete, and just said, mate, how can I join this company fast enough? It's just that cool. But anyway, that's my backstory. Let me show you how many records are in the table, if this decides to show up here. All right, so we've still got the 100, that's just not rendering here, but we've got 129 million rows or 130 odd million rows in this table. There we go, that's showed up for you now. I'll blame that on the resolution. So there's our 129 million records. I'll make this a little bit smaller, just give you guys a zoom there so you can see it. There they are. I'm going to drop that so that those are gone from my production environment. And you guys have probably already seen what I'm about to do here. In Snowflake, you never again need to back up data. That's one of the features that we always call out in Snowflake. All of the things that you no longer have to do. There's actually 3 reasons why you would ever do a backup. This covers off only one of them. I'm going to talk to the other 2 if we have time. But this is essentially if you make a mistake in production, what do? You need to fix it, right? So we now have no records in this table. I'm going to get an error here because, of course, we've dropped it, right? The table's gone. Now, in any other data warehouse, you're looking at backups that could take you, I don't know, I'll be nice and say 8 hours, but that's being nice. Now, in Snowflake, I just say undrop table. So that was, what, 67 milliseconds? And there's my 130 rows immediately back there, right? You can't make a mistake in Snowflake. It's not possible. Anytime you do anything in Snowflake, by default, you generate a unique query ID. And with that unique query ID, you can fix any problem, no matter how complex it is. And you guys are welcome to come over to our stand after this demo, and I can show you how complex those problems get, and we will fix them, and I promise you that. What we're going to do now is do something a little bit more complex than what we've just done here. You guys will remember that Kelly deleted 900 million records from my table through DML. Now, that was production-grade data. I want to get that back. That should not have been deleted, right? My customers called me up and said, James, that's important data, bring that back. So all I need to do, again, talking about that unique query ID, is search through my information schema of my query history for the last query that was like the word delete, right? I search through for that. I'm setting that to a session variable, which is called a query ID. I'll just zoom back out here. I'll show you that query ID that we've just found. We found it. That is the delete statement that Kelly ran that dropped out those 900 million rows out of my table. And now I can use the feature that's called time travel. I'm giving you guys 2 select count stars here. One is the current table, and one is literally using the word before the query ID to show us how the table was before that query ID, right? So I run this, and I've got my 129 million rows, but I've still got my billion records. It's still there. We never actually dropped it. The DML didn't kill it because we retain everything in Snowflake for up to 90 days. Now it's time to fix it. So I'm going to actually create a table called trips before to try and get the table back to the way it was before. I'm going to clone the current trips table, but I'm going to add in time travel. I'm going to say before the statement ID of query ID. In just under a second, I've created that table because again, this is just like a DDL metadata operation I'm performing here. I'm not actually having to do any replication. This all just runs fast. Now I'm going to swap the trip table for the trip before table, so I'm back in my production table. I'm then going to drop the trip before table. I don't need that anymore. And this is kind of the ta-da moment where we run the count star from the new trip table, or the trip table it was before I corrupted it, and my billion rows is back in my trips table, right? So again, any single thing you do in Snowflake can be fixed. It doesn't matter if you started making changes to that table over time, we can still fix that through joins and other intricate ways of working with time travel. So that's pretty cool. I'm going to jump back to the slides here really quickly, and I'm going to race through them because I know I've only got about 2 minutes to go here. This is just a very quick summary of all of the features that I went through today. Anyone wanting these slides, we can give these out. But just have a look at some of the logos that we've got up there. We've got a very rich ecosystem. Snowflake is a cloud-only data warehouse. Regardless of that, these are just some of the very few tech integrators that have built native connectivity into Snowflake. They've leveraged ODBC, JDBC, Python. You can see there's a bunch there for ETL, ELT, all of the different BI tools that you can use, data science. We've got an incredibly fast Spark driver. You guys work with machine learning and AI, do it through Snowflake with our pushdown, and it's phenomenally fast. You can leverage the power of our compute, and that's what's so unique about Snowflake, that compute layer. You saw me spin up 64 nodes of EC2 just like that and just run a query, paid for it for a minute, and it shut down. All of the features are up there. I won't go through them again. What are customers doing with Snowflake today? This is just to give you a bit of a look, and I probably already mentioned this, that customers today, due to contention on their system, are having to spin out data marts. That's no longer the case in Snowflake. You don't need to spin out multiple data marts to deal with control and contention. You simply load everything into Snowflake. You can have as many petabytes as you want. It doesn't matter. We actually pass through the cost of S3. Our storage layer is S3, $25 per terabyte per month. It is phenomenally the most cheapest data warehouse on the market today from a storage perspective. In other ways too, but especially from a storage perspective. We utilize that blob store, but we make it hyper fast to make everything always analytically available to you. If you think about all of the data that exists in the world, and I know I've run over time here, I'll just be another 2 seconds, you can really break it into 3 parts: structured, semi-structured, and unstructured. The first 2, Snowflake works perfectly with from a data lake perspective. Just to really race through this, I'm not going to talk to these customers. I've got some awesome stories, but Capital One, Goldman Sachs, AT&T, all of these guys have gone all in on Snowflake, and they're having massive wins out of that migration. And there's super cool stories there. I won't harp on those. We're being recognized by all the leaders. We're on all of these quadrants. You guys know who all these guys are. We're up there. Snowflake is a leader. So much to remember. This is where I just really quickly call out George Miller, clinical psychologist in the 1950s. Did a lot of work, researching human short-term memory. Anyway, he came up with Miller's number. Most people in their short-term memory can remember between, 6 and 9 things, 7 plus or minus 2. That's called Miller's number. They are the 6 things I talked about at the start. Please remember those. These are all of the things that Snowflake can bring to your organization. Everyone else can do 1 or 2. We can do all 6. Sign up for free on our website. You get 30 days free, 400 USD of free credits. Just try it out. It's that easy. And you're not alone. We've got a bunch of amazing tech partners. So talk to these guys. They're born in cloud. They're amazing. They're some of AWS's best tech partners. They will help you on your journey in Snowflake. So thank you, guys.